If Java already provides the synchronized keyword, why did it introduce ReentrantLock? At first glance, both seem to do the same thing. They allow only one thread to access a critical section at a time. So why do we need another locking mechanism? The answer is simple. Both synchronized and ReentrantLock are reentrant. The difference is that ReentrantLock gives developers much more control and flexibility when managing threads in complex concurrent applications. Let's see why.
Yes, the synchronized keyword is already reentrant. Imagine a synchronized method A calling another synchronized method B on the same object. When the same thread enters method A, it acquires the object's monitor. Later, when method A calls method B, the thread doesn't block itself because it already owns that monitor. Instead, Java internally increases the lock's hold count. When method B finishes, the hold count decreases. Once the outermost synchronized method completes, the lock is finally released. That's why both synchronized and ReentrantLock are called reentrant. Unlike synchronized, ReentrantLock requires you to manage the lock yourself. You explicitly acquire the lock using lock method. After completing the critical section, you must explicitly release it using unlock. Always place unlock method inside a finally block so the lock is released even if an exception occurs. This explicit lock management gives developers greater control over how locks are acquired and released. Now let's look at one feature that synchronized doesn't provide. Suppose one thread is holding a lock for a long-running task. Another thread starts waiting for the same lock. Now imagine the user cancels the operation or the application begins shutting down. With synchronized, the waiting thread must continue waiting. With lockInterruptibly method, the waiting thread can be interrupted. Instead of waiting indefinitely, it immediately throws an interrupted exception and can safely stop or perform another task. This makes applications much more responsive.
Sometimes, waiting forever for a lock isn't acceptable. With tryLock method, a thread can wait only for a specified amount of time. If it acquires the lock within that time, it continues normally. Otherwise, it gives up and handles the situation without remaining blocked indefinitely. This is especially useful in applications where responsiveness is important. By default, ReentrantLock is unfair. This means there is no guarantee that the thread waiting the longest will acquire the lock next. As a result, some threads may repeatedly miss their turn, leading to thread starvation. If fairness is important, create the lock using new ReentrantLock method. With true, this enables fair scheduling, where waiting threads are generally given the lock in the order they requested it. Another advantage of ReentrantLock is support for multiple condition objects. With the synchronized keyword, every object has only one waiting queue. ReentrantLock allows you to create multiple condition queues. For example, producers can wait on one condition while consumers wait on another. This provides much finer control over thread communication. Clip 8. Let's summarize. Both synchronized and ReentrantLock are reentrant and provide thread safety. However, ReentrantLock offers additional capabilities including explicit lock management, interruptible locking, timeout-based locking, fair scheduling, multiple condition objects. Use synchronized for simple synchronization. Choose ReentrantLock when your application needs greater flexibility and advanced concurrency control.